Okay. This is the second part of 3-2, which is over logarithmic functions. The first part, we evaluated them and learned how to rewrite exponentials as logarithms and vice versa. Now we're going to work with graphs of logarithmic functions. Okay, and we're going to be using the exponentials to get us started. So, this will sound familiar because you did the same thing with the exponentials in 3-1. Sketch and analyze the graph of each function. Describe its domain, range, intercepts, asymptotes, and behavior, and where the function is increasing or decreasing. Okay, so use red, I guess. All right. So the first one that we're going to graph is f of x equals log base 2 of x. Now we could put this in the calculator, but the way we're going to do it is so that you can see the inverse, how it's an inverse. We're going to graph its inverse first, which is an exponential. So the first thing we're going to graph is the inverse, which this is inverse notation if you remember. So the inverse of log base 2 of x is 2 to the x, where your 2 is your base. Alright, so let's make a table. And this is the table for the inverse, 2 to the x. Alright, and we will start with the value -2. Now we can put it in the calculator, but we can do it pretty quickly over here. If I have 2 to the -2nd power, that's the same as 1 over 2 squared, which would be what? What's 1 over 2 squared? 1/4. Which I'll put 0.25, we'll put the decimal. Alright, if I have 2 to the -1st power, that's 1 over 2 to the 1st, which is what? 1/2. Now the rest of these that we're going to do, I think we can do in our head. Alright, so I have 2 to the 0 power. What's 2 to the 0 power? 1. Anything to the 0 power is 1. 2 to the 1st power. So if x is 1, y is 2. 2 to the 2nd power. 4. Y'all are kind of asleep or something. Alright, 2 to the 3rd power. 8. Alright, so let's go over and let's go ahead and graph that one. Now this is the exponential. It should look familiar from lesson 3-1. So, -2.25, -1.5, 0, 1, 1, 2, 2, 4, 3, 8, and then I'm still having trouble drawing on this thing, so you may have to imagine that this is just a really nice graph. Oh, it's not bad compared to some of the others I've done. Alright, so does that look familiar? Do you remember that exponential growth function? Okay. Alright, now we're going to graph the log base 2 of x, which is the inverse. They're inverses of each other. So this table is going to be the log table. Now, when you have an inverse, the x and y switch places. That's how you can graph an inverse if you're given a function. Just switch the x and y's. So, we have 0.25 -2, which comes from here. We're just switching them. 0.5 -1, 1, 0, 2, 1, 4, 2, 8, 3. So, 0.25 negative 2 would be about right here. 0.5 negative 1. 1, 0. 2, 1. 4, 2. And 8, 3. So inverse functions, if you graph them, they should reflect over y equals x. And y equals x is that basic or parent linear function where the y is equal to the x. So if x is 1, y is 1, and so on. Anyway, you get the idea. Okay, does it look like it reflects over that? Okay, now we're going to analyze this and tell all those characteristics that are listed. Okay, so first thing we talked about is domain. What's the domain? Now, this is of the red one. We're not doing the domain of the purple. That was lesson 3.1. Just the red one. What's the domain? Left to right. Where does it start on the left? How far does it go to the right? Where does it start on the left? At 0, but it doesn't include 0. And then how far does it go to the right? Forever. So your domain is 0 to infinity. Now, if you think back, that was the range on the other one, on the exponential. All right, what about the range on this one? Low to high. Good. Negative infinity to infinity, which was the domain for the purple one. All right, intercepts. X-intercept. Do we have one? Yes. Where does it cross the x-axis? At 1. So 1, 0. On the purple one, the exponential, there was no x-intercept. All right, what about y-intercept for the red one, the log? Does it cross the y-axis? No, so none. So those are right opposite for the exponential. All right, what's next? Asymptote? I'm just going to put an A for asymptote. I get tired of writing that thing over and over. All right, so on the exponential, the x-axis was the asymptote. For the logarithmic, what's the asymptote? The y-axis, there's a vertical asymptote, okay, which would be x equals 0. Okay, in behavior. Now, your in behavior is a little bit different for going to the left because you're not approaching negative infinity going to the left. You're approaching 0. So your left in behavior is the limit of f of x as x approaches 0 equals, and what is y doing as x is getting closer and closer to 0? Where's it headed? Negative infinity, because it's going down forever. Now moving to the right, the limit of f of x, x is approaching infinity. Now what is y doing as x is getting larger and larger? What's y doing? Getting larger and larger. So it's approaching infinity also. All right, and then last, increasing or decreasing. All right, moving from left to right, what is this one doing? Increasing. So it's increasing over the domain, which is from 0 to infinity, not including 0. Which I find interesting because this one's increasing also. So even though they're inverses, they're both increasing. All right. Now we're going to do f of x equals log base 1/2 of x. So let's write our inverse. The inverse is what? What's the base? 1/2 to the x. Now this one, let's just put in our calculator real quick. So we're going to do the inverse first and then switch to x and y's. So let's do -2, -1, 0, 1, 2. Alright, you can just do the calculator if you want to put 1/2 to the negative second power. What do you get? Some of you may do that in your head. Flip the 1/2 and square it, basically. Huh? Be 4, wouldn't it? Alright, what about 1/2 to the negative first power? 2. 1/2 to the 0 power? 1. 1/2 to the first power? 1/2 or 0.5. And 1/2 to the second power? 1/4 or 0.25. Alright, let's go over there and graph that real quick. Oh, I hit the wrong thing every time. -2, 1, 2, 3, 4. -1, 2. 0, 1. 1.5, 2.25. Let's see if I can graph it with the thick one. I figured out I'd do a little bit better with this if I don't try to go too far at one time. Okay, so that is an exponential decay, isn't it? Okay. Alright, back to the purple. Alright, now we're going to do a table for the logarithmic f of x. How are we going to get that table? Switch the x and y's. Good. Okay, and then I'll give you a minute to graph that, and I'll graph it too. Now, is it a reflection? Does it look like it's a reflection? Because what is it going to reflect over? Well, the y equals x. If it reflect, well, never mind. That'll get confusing. Alright, and it does. You can see that it reflects. Okay, so now, back to our purple one. And all of those characteristics. So, domain. Same as the other one? 0 to infinity? Yes, starts. Doesn't go any further to the left than 0, and it doesn't touch 0. So it doesn't include 0. What about the range? Low to high. How low does it go? How high does it go? Forever both directions, right? So that didn't change from the other one. All right, intercept, x-intercept. Is there an x-intercept? Yes, what is it? 1, 0. Same thing as the other one. All right, what about a y-intercept? Does it cross the y-axis? No. It runs right up next to it, but it doesn't cross it or touch it. Asymptote. Is it still this y equals 0? I mean x equals 0, the y-axis? In behavior. Okay, as you move to the left, if you're moving left, you're not approaching negative infinity. You're approaching 0 going this way. And what is y doing as x is approaching 0? It's getting higher and higher and higher, right? Forever, so it's approaching infinity. Okay, now on the right, the x is going forever and ever and ever. So the limit of f of x as x approaches infinity. And what is the y value doing as we move to the right? Getting higher, getting lower, approaching a number. What's it doing? Getting lower, so it's approaching negative infinity. And then, moving left to right, is it increasing or decreasing? Decreasing. Just like the exponential one. Its inverse is also decreasing. And that would be from 0 to infinity. Okay? Any questions about that? Alright, so here we go. The first one that we graphed, the log base 2 of x, is a logarithmic growth. And it's an inverse of an exponential growth. Okay? Then the second one that we graphed, log base 1/2 of x, is a logarithmic decay, which is the inverse of an exponential decay. And there are all those things that we talked about. I added a few things, or wrote it the way we've been writing it. Okay, moving on to transformations. Okay, the base function, yeah, cheater, I learned. The base function, or the parent function, is log base b of x. Okay? That is a basic parent function. That's what we just graphed. Log base 2 of x, log base 1/2 of x. But you can have lots of other things in a transformation. Lots of different negatives, other numbers can make that graph do different things. So if you have a negative out front, and this should look familiar because it kind of goes along with all the other functions, which is kind of cool because all of our functions kind of work the same. A negative out front is going to make the graph, the original graph, reflect over the x-axis. A multiplier out front is going to be a vertical stretch or compression. A negative inside the parentheses with the x would be a reflection over the y-axis. A multiplier in front of the x. Oh, I didn't put that one, did I? I just thought I was ready. That will be a horizontal stretch or compression. Then, if we're adding or subtracting a number inside the parentheses, that's going to be a horizontal translation. And if it's positive, it'll go left. If it's negative, it'll go right. And then a plus k, plus or minus a number right here, is going to be a vertical translation, positive up, negative down. Okay. All right. Use the graph of f of x equals log x. Now there's no base. Uh-oh. Is that a typo? Good. If there's no base, that means it's a common log and the base is 10. So, we're going to describe the transformation that results in each function, then we're going to sketch the graphs of both functions. So let's go ahead and do this one. So, you can use your calculator. Okay. So, let's get a graph for x, f of x. Then I'll tell you the transformation. Now, what would be the lowest number I would want to start with right here for my x value? We can't take logs of negatives. Okay? So, and 0, it doesn't, you can't take log of 0 either. So it's going to have to be something greater than 0. So we'll start with 1. We're going to do 1, 5, and 10. So can somebody do log of 1 on your calculator? Which if you think about it, that would be 10 to the what power equals 1? Anybody get it yet? 0. Because your base is 10, and if you raised it to the 0 power, you would get 1. Okay? So this is the exponent for the exponential function that goes with it. All right, what about 5? What'd y'all get? 0.7. And then what about 10? 1. Because 10 to the first power is 10. All right, so let's go over here and graph that one. Now notice with this one, it starts flattening out really quickly, doesn't it? So it almost looks horizontal. All right, now what we want to do now we want to graph, because I haven't told you what we're graphing yet, the transformation. The transformation that we're going to graph is, put my paper down here, P of x equals, what is that? I wrote something funny down. All right, log of x plus 1. In parentheses. The plus 1 is inside the parentheses. If the parentheses weren't there, if it was just log x, then plus 1, that'd be a whole different problem. It would move a different direction. All right, so how many transformations do you see of the original? 1. And it's this plus 1 right here. So what does that plus 1 inside mean? It's going to go to the left how many units? 1. So rather than make a table, let's just move each point to the left 1 unit. So our x-intercept is going to change. Our asymptote will change. Our asymptote is now going to be, it moves to the left 1 unit also. So instead of the y-axis, your asymptote is at -1, which also changes your domain. Your domain, instead of being from 0 to infinity, is now from -1 to infinity. And they almost just lay on top of each other as you move to the right. Okay. So is that what y'all got? Everything moved to the left. Now we're not going to write down all the different changes. We just kind of talked about them as we went. The asymptote changed. The y-intercept changed. The domain changed. Your end behavior going toward, instead of approaching 0, would be approaching -1 now. Alright. So you have to be careful. Okay, on this one, let's go ahead and do our log function first. Let's go ahead and graph it. You don't have to redo a table because it's going to be a transformation of the log function, the common log. So 1, 0, 5.7, right? And 10, 1. Alright, and I guess we'll call this, the other one was, I didn't mark it, but we'll call it, it'd be 6a, so this would be 6b. So we're going to do negative log of x minus 2, but no parentheses. So how many transformations do we have here? 2. What is the negative out front going to do? Reflect over x-axis. What's the minus 2 at the end going to do? Outside the parentheses. That's the k. So which direction is it going to go? Down 2. Alright, so when we graph it without making a, try to do it without making a table, you're going to reflect it over the x-axis and then move it down 2. Okay, so if you reflect this point over the x-axis, it doesn't move because it's on the x-axis. So we're just going to move it down 2. Alright, if we reflected this one over the x-axis, it would be at 5, negative 0.7. So we're going to need to move it down 2. So it would be at 5, negative 2.7. And then 10, 1 reflected would be 10, negative 1, but you got to move it down 2, so it would be 10, negative 3. So there you go. Alright, we're going to stop right there. And there's one more, but do you think you have the idea of the transformations? Okay, and it could be any. It could be log base 2, it could be natural log, okay? But the transformations work the same no matter which log it is, okay?